right? We'll create a basic renderer which will be able to draw chords, right? And chords means basically quadrilaterals, right? There's something, and we'll mostly work with rectangles. And the reason for that is because we are going to make a 2D game, and which will mainly focus on rectangle, and then we'll later on expand this rendering layer to draw various shaders, and also to be able to draw texture with that. And then we can use the same renderer to draw text on the screen. And so we will be doing those things later on as we expand our rendering layer, but we are gonna just set the foundation of our basic rendering layer so you can draw something onto the screen. And for that, currently we won't do anything. We'll just write everything in this specific particular way, but then we'll later refactor it into the separate game layer. So our platform layer will be independent from the game layer, and they will talk in between. So we'll be able to do something like that, but for now we don't care about that. So how you can draw into the OpenGL, right? So OpenGL is a state machine, right? So OpenGL API is defined as a state machine. So OpenGL has a like global state, right? Which will say global state, and it has a lot of parameters, lot of values you can set and unset. And its API is also designed in a way that there are functions who actually set some variables in this global state, and there are functions which basically tells OpenGL that okay, these are whatever variables we have set currently up till now. Use those variables and do something with those variables, like draw or do something. Yes. So first of all, we'll need some form of data, right? And also how we do rendering at a very basic level is that we give OpenGL information about what we want to draw, basically what kind of geometry we want to draw. So if I want to draw triangle, and triangle is the basic shape, is the simplest and the most foundational shape that graphics driver can draw, right? And it's designed to draw these triangles very fast. There are mathematical reasons why we chose triangle as like fundamental shape. One of the reason is that it's the simplest form of a shape which comes after line, right? So line has 2 points, triangle has a 3 points which covers the plane, line does not, you can't. Yeah, so basically the one reason is that, and the most important reason is that any 3 point of a triangle is a planar coordinate. It creates a unique plane, right? So there is no other shape in which the points you take can create a unique plane, right? So you can't create a triangle without creating a unique plane which pass through all the 3 of the points, right? And which is a very important property in terms of the mathematics of drawing triangle, rasterizing the triangle, and then drawing it to the screen. We'll not go into the much more detail of how this math works, but we'll understand some of the basic fundamentals. So triangle is the basic shape which we can draw, and then we can create more complex shapes. So basically, if you want to draw a rectangle, we can always convert a rectangle into the triangle by bisecting through the diagonal, and you can do the same things with complex meshes. So that's what we call this thing a mesh. The mesh is basically a collection of points which have information about the geometry or surface of a particular thing of whatever we want to draw. So mesh has data of positioning of the points. It might also contain information about the color of the mesh. It might contain information about the normals of the surface and a lot of other information also. It has like UVs and stuff, which will go more into the detail, but mesh is not much important because we are creating a 2D renderer. If we do 3D, then mesh is a very important topic in that. But for 2D, we don't need anything complex. We just need a rectangle, not even rectangle, like a chord, basically. It's a square, not even a square. Like chord means quadrilateral, so it can be like anything which a shape which can be created from 4 points, basically. Right? Yeah. So we basically provide OpenGL with this data of a like position of like, okay, where this position is, where is this position is, where is this position, and then we also give this position in order that we want to collect. So we want to connect these points, like we want to connect this point, and then this point. So the order of our data would be also in the same order. You can also pass in the information such as colors, UVs, which we'll do in the later when we expand a layer. But for now, we'll just give the position of the points. And to give the position of the points to OpenGL, so OpenGL is basically just an API to communicate with like whatever graphics hardware, right? Whatever hardware we have, like either you have NVIDIA, AMD, Intel graphics card, whatever graphics card you have, like it's a simple API to just communicate with the hardware. So first of all, we need some form of memory in our GPU where we can give this data, right? So one of the most important steps we have to do, first step, is to get some amount of memory in the GPU, right? Once we get the memory, what we do is we have memory in our CPU which contains this data, and then we transfer our CPU data to the GPU and let OpenGL, and then we call a draw function which takes this memory and then draw it right behind the scene, and now it does like every math it has to do for rasterizing our particular points and how it will draw onto the screen. In between this draw call, there are multiple steps which you will also have to do. One of the step is programmable shaders. So shader so shaders are very fundamental concept for drawing something in OpenGL, because what it allows us to do is how it will be able to draw this, like what kind of color it is, and we can do a lot of complex mathematics in terms of like light, how light up this particular thing is, or camera projection, perspective projection, orthographic projection. There are lots of stuff which we able to control because of these programmable shaders, which are in middle of the pipeline before we draw something, right? So whatever data we have given to draw, we can also change that data in some way that it helps us to draw something in more so basically we have more control over how the things are drawing. It's not just very fixed drawing. Like this is the place where we control how we want to draw stuff, right? So we can basically tell GPU that I want this particular color over here, this particular color over here, and we can do this in a very mathematical way, right? And yeah, that's it. And for shader to work, shader to understand this data and take this data in and do this different maths on it, so we have to set up some more stuff, and that's it. that's all we have to do to get something working. It's a little bit tedious, but once you get understanding of what is the pipeline of it, then it becomes very easy open, right? So as I told you, so one of the first thing we need is we need a buffer, right? So how we get the buffer? So what we'll do is we'll just search learn OpenGL, and this is a very great site. It is like very really good site to get things, to understand some concept of OpenGL, and to get some uh, information about how OpenGL works. It has lots of good examples which you can learn, which you can just go through and learn, right? So that is getting started. What we want is a hello triangle, right? So as you can see, it will have a little bit deeper understanding of the whole pipeline of the OpenGL. What I've covered is very bare minimum. So we have this vertex data, which is a data of the shape, and then it goes into this kind of things, and then it finally comes onto the screen. You can read about it much more deep. So this is yeah. So first thing we're gonna do is in our, we can also do it in the same loop. Let's do it here. Okay. So we'll create uh, we'll we'll create a point, we'll create a data, right? So let's say I want to draw this triangle, so I'll have to create data for this triangle, right? So what I'm going to do is I'm going to create an array of float 32, right? And why it's a float? Because it will take points. So let's start with this point. So as we know, our OpenGL currently, this is our screen, right? So my OpenGL coordinates are -1 to 1, and then -1 to 1. I think I'm wrong. Like it's -1 to 1. Yes. Right. So if I want to draw a triangle, like in the middle of the screen, this point becomes -0.5, -0.5. This becomes this becomes 0.5, -0.5, and this will become 0, 0.5, right? So we need this information of position of vertex, and because for that we'll just create a float array, and then we'll start with this vertex. So we'll just store -0.5, -0.5, and because we are only working with 2D game or 2D rendering, we don't care about our z coordinate, so we only have 2 coordinates for this, and then we take this, so this will become 0, 0.5, and then this becomes 0.5, -0.5, right? So we have basically a simple data for drawing a triangle, right? So we call this vertex, so vertex of the triangle. So this is like vertex data, right? And now, so it explains all these stuffs here also. Now, as I told you, we have to create a buffer, right? So to create a buffer, you have a function called gl generate buffers, right? And you call that, and it takes in unassigned integer. So basically, when we create a buffer, OpenGL gives us its ID in return, and we can use this ID when we want to use this buffer. We want to bind this buffer, or whatever we want to do this with, whatever we want to do with this buffer, we can do it with that ID, right? So let's create a VBO. So VBO stands for vertex buffer object, right? So it's a vertex buffer object, and then we can use gl generate buffers, and we want to create only one buffer, and then we pass in the address of VBO. So this will be filled up with the id. This will be filled up with the id of whatever this buffer. Yeah, so basically we'll get the id of generated buffer in VBO. Now we need to bind this buffer, right? So as we know, OpenGL is a state machine. So now we are setting our state of global state that okay, I have created this buffer and now I want to use this buffer. So I want to bind this buffer, and I have to also specify that what kind of buffer it is. So what kind of buffer is it? So this is array buffer. So there are different buffers in OpenGL which will once we go through those we'll talk about them. But currently we want G array buffer, and array buffer is basically simply just a memory in GPU which is straight memory. So we'll just do GL array buffer, and then we'll pass in our buffer ID, right? So now this buffer ID which we have created is binded in the OpenGL state machine, and now whatever we do, now there are functions we can call in OpenGL which will take in whatever buffer is binded in the OpenGL state machine, and then we'll do stuff on that buffer. If we don't bind the buffer and we call the function directly, either it will execute on whatever buffer was binded before, right? Whatever previously binded buffer was, and if there was no buffer binded, it will give us an error. So now there is a function called GL buffer data, which what this function does is whatever the current binded buffer is, we can pass in our CPU data, and it will copy the CPU data and then uh, copy it to the GPU buffer which we have created, which we have binded, right, in this step. So now we have GL dot buffer data, and this takes in also that what kind of buffer this is. So we know that we want to work with array buffer, right? It takes in size of vertices. Let's also currently in here we are not sure what documentation we are. So for documentation you can search GL docs, right? And then in the docs here you can search. This is a really good documentation for OpenGL, and there are multiple versions. We'll be only using GL4, so we can search GL buffer data, right? And we can click on GL4, so we get this nice documentation. What kind of parameter does it take? So GL buffer data takes in target, which is array buffer. Then it takes in the size, then it takes in the data and how we're gonna use this buffer, right? So target, there are lots of this kind of buffer. We are gonna we mostly gonna use array buffer, but there are different buffers which we also can use, but currently there is no need for that. Then there is a size, specifies the size in bytes of the buffer object's new data store, right? So basically how many bytes of the data we need to copy, right? So for that we know that the float, we can just do size of float multiply by length of this, right? So we can calculate size here like this. So we can do length of vertices and then multiply this by size of float 32, and then we can pass in size. We can also print it to check if it's right. So let's do that. The next is data, specify the pointer to the data, right? So the pointer, we need pointer to the data, and how we can get this is basically we have this array and we can just pass in like this pointer to the first element of the data, which will then be the pointer array. And then how we want to draw this. So currently we are gonna So there are multiple, so there are GL static draw, dynamic draw, right? So what's dynamic draw means is that I'm gonna use this buffer, and my buffer value, right, could be changed multiple times. Static draw means I want to draw from this buffer, but my buffer will have my buffer, once I set one time my buffer, it won't change later on, right? It can never change. Once I set my values into this buffer, it will never change. So currently we don't want to change. So yeah, it's just something which OpenGL takes into the consideration to optimize some stuff which it has to do with the buffers, right? Whatever they have to do in the memory, in the graphic side, the driver side, it does some of the optimizations there using whatever we are using here. So there are like description of what this means, what string means, what static means, what dynamic means, what draw means, read, copy, that you can understand what are the use cases of it, and then use it according to your needs. So if I do this, it does not give any error. And also one thing I want to check is what does this takes as a parameter. So I can just search buffer data into the OpenGL report. Yeah, so it takes a raw pointer. We can also do this. If we don't have to do this, we can just do raw data like this, and yeah, that would also work. So now we have set we have copied data to our GPU memory. Now next step is to create a shader, right? So as I told you, we have a shader and everything goes through the shader in between to draw some stuff. So let's create the shader. So what I'm gonna do, I'm gonna just go here and then I will just create a basic vertex shader. What am I doing? Yeah, and then we'll basically create a multi-string stuff. And first of all, we need to define what version we are using for this shader. So as we know, we have defined the GL major and GL minor. So we are using 430. So we have to specify here 430 and then core, because it's a core OpenGL. There is a old OpenGL, but nobody uses that right now. And now we also have a main function, right, which we use. And now, as I told you, now how does this shader, so what shader does is whatever data we have set in this buffer, it takes that data and then we can manipulate that data into this main function. We can write a logic into this main function to, if you want to manipulate any of the data which is in the buffer, right? Whatever data is in the buffer, we can manipulate it. But how does the shader know that what data it has to take in from this buffer data? Because buffer data has just plain data, that shader has no understanding of how to parse this data into some form of parse this data to get some meaning out of it, right? Let's say it's just array of floats. Now it does not understand that this two float becomes a one thing and one vector, which is x and y coordinate, and it's a position of a one vertex. This is the position of second vertex, this is the position of third vertex. It does not know by default. So we have to do something here so that shader can understand and parse this just raw data into something meaningful, right? And to do that, we have attributes, right? So these are like attributes. So to define attributes, we have to define layout. and then we also need to define which location this is, and we'll understand where the location comes into the play, but currently just bearing. In means this is something which we are taking in from the buffer, right? And then as we know, we are so vec2 is basically data type into the shader in GLSL language. So this is whatever we are writing is GLSL language. You can go and do some research, and you can look into something more, code in GLSL, and you will understand what this is. So this is basically data type in GLSL, which is comes by default, and then we can name the variable which would be a pose, and what this means is attribute position, right? And it's a vector2 because we have two x and y coordinates which defines one position, right? If we had three coordinates x, y, z, then we will here have one more float for all these positions, and then we'll take in vec3. But currently we are only doing stuff with 2D. So yeah, so now we have this position, and now here we need to pass. So this GL position is a default variable inside this vertex shader. So this is the vertex shader. There are two shaders. One is vertex shader, one is fragment shader. What vertex shader does is it takes in this buffer data, right, and takes all the information about the vertex, right? Either is position, color, UV, texture, like normal map, anything information inside the buffer. It takes it parses the information, and then we can do calculation based on each vertex, right? So this main function will be getting called for each vertex, right? And so each vertex we can do some maths on it, but currently we don't have to do any maths. This GL position takes in vector 4. We have here vector 4, so we have to do this a position, and then for vector 4, for our z coordinate would be 0, and then our w coordinate would be 1, right? And that's it. So now the same way we'll also define basic fragment shader, right? And this would do the same thing. We have to define a version 4.4. So we have to do the same thing. Now fragment color, what fragment shader does is that it runs after the vertex shader, right? And whatever the vertex shader has done, you can also what we can also do in the vertex shader is that we can do some calculation in vertex shader and then pass it to the fragment shader. So if we do here, we have done in keyword, which what it does, it takes in something, right? We can also do some variable with out parameter, like out attribute, and what it does, it gives that variable to the fragment shader to do some more calculation onto it, right? In rasterizing, we have this triangle. So in screen we have this pixel, right? So we have lots of pixels here. So what this in between the vertex shader and fragment shader, what it does, it takes these points, these 3 points, and understands how many pixels are in this area, right? How many pixels are in this area, and it will convert into the fragments. And now for each fragment, this fragment shader will be called, right, for each fragment, and then we can do some amount of calculation here to show what colors we want to show, like either if you want to do shading, if you don't want to do shading, anything you want to do with this drawing part, like onto the fragments will be done in the fragment shader, right? So currently we don't want to do anything in the fragment shader, right? So what fragment shader does, it outputs the color, right? So here, as you can see, it out attribute onto this vector 4. Vector 4 is basically color, RGBA, alphabetic, red channel, green channel, blue channel, alpha channel, and then it takes in these 4 RGBA values and it outputs the color of this particular fragment, right? So we'll have to define out vec4. So we can just do out color, which is 4 color, and then we have a main function, and here we can just do O color is equal to vec4. We can just do white color, or yeah, let's just do white. So like this, and now fragment shader is done. Now there are particular things you have to do to compile this shader and to create. So this both shader becomes one program, because both shader, as I told you, works in hand to each other. So we create a program. We first compile the shader and then attach the shaders to a program, which is just a program in OpenGL, and then we bind that program. That okay, I want to use this particular program which consists of these two shaders, and I want to use this program to draw something. If we want to use some other shaders, we can just have those shaders in other files, and then we can load those shaders, and then we can bind that particular program. That okay, now I want to draw this particular thing with this program and this particular thing with this program. So you can do those kind of things, and to uh, to allow us to do that, OpenGL has some stuff, right? So let's do that. So you have to create shaders, and you have to compile them, you have to check it for errors and stuff. But for now, in Odin language, we have helper functions. In helper functions, we have compile shader, create and link program, right? So this is there are some load shader files. Load shader source, yeah. So we have a function which does these things for us. We don't have to call this crazy function. So there is a function called load shaders from source, and it returns us the program ID, which we'll use to bind this program to use into our draw function, into our draw call. And then it also returns us okay if it succeeded or not succeeded in compiling shaders and stuff, right? So we'll use this function, load shader function, load shader source, and we'll do it we can do it in the frame each time, or we can just do it one time so it depends on how you want to do it. What we'll do is we'll just load it one time, and we'll call this program, right? And we can call this function, and this takes in two string parameter, right? One for vertex and one for fragment shader. So we'll just pass in basic, the name of our shader, drag and vertex, and that's it, right? So now it will load us, and it will give us two variables, one for program and one for OK, which is kind of like error handling. So if OK, yeah, so we can just here do format.println print OK. So we can just if there is an error, we can check our shaders and do other things if you want to do. So our shader is basically compiled and attached to this program, and now we can use this program. But before that, so we can link program, and we can then use the program. Now, as I told you, so now we have shaders working, but the important part was this layout location, right? Like how does this work, right? So it does not do anything magic. We have to tell it that how the vertex shader will use this function, how vertex shader will use this data to parse it into the information that is some meaningful information to the vertex shader. So for that we have VertexAttribArrayPointer, right? And for vertex vertex attrib pointer, we also need vertex array object, right? So what vertex array object does in this new OpenGL's way of doing things is vertex array object binds all these vertex attribute pointers, which we will define to give some meaning to this raw data, like what is position, uh, how much points, like how much coordinate does it takes to make a position like xy coordinate, or or is it xyz or something like that, what color is it the vertex, or what is the uv coordinate here, and all those other information can be here. But currently we just have only position, so we'll only deal with the position. So we have this vertex array object. We also have to create uh, so I'm not sure if they are doing, yes, so they are doing it. So there is vertex array object, which is VO, and then we have to call this uh, generate vertex arrays, right? So gen vertex arrays, we only want to do one, and then we will find this. And now also we want to bind it, so for binding it we have to call gl bind vertex array. So you can just do it here, gl bind vertex array, and then we can bind our view. And now once we bind our view, we can define our vertex attributes, vertex attrib pointer, like this, right? So first we have to enable our vertex attrib arrays. So we can do enable vertex attrib array, and this takes in the location, right? So what this 0 means is that this location is now enabled, right? So we have to enable the location, so this 0 is directly related to this 0, right? So we have enabled a 0th location to do something, and now we can attrib pointer, vertex attrib pointer, and now we can define that on this 0th location, so this is the location, so we can also go here and search for el vertex attrib pointer, right? Yeah, so it takes in the index, so this is the index of the layout location which we have specified here. So this particular 0th index, 0th location, what it is, like how does it convert our raw data to this position data, right, which is a x and y coordinate. How does it convert? We define it here, right? We define in this function. So it takes in the size, right? So size means how many elements are we using for these things. So we know that it's a vector 2, right? We know it's a vector 2, that means x and y coordinates. So we'll do it 2 because it's x and y. If we had x, y, z, you would put it 3. If we had x, y, z, w, or for color, if it would have been R, G, B, A, then it would put it 4. Like it's how many elements we have to combine it to give some meaning. Right? The next thing is the type, right? So what type of data it is? So we know it's a float type, right? And for that we have a type called gl float, right? So this gl float, so we'll just give this here gl float, right? And now next is normalized. Do we want this data to be normalized or not? So we don't want it to be normalized. Then there is this two important part. Yeah, then we have these two important part, which are stride and pointer, right? So what stride means is basically how much bytes I want to offset my data to get to the next vertex, right? So this is my first vertex, this is my second vertex. So how much I have to shift my pointer from this particular place to get to this particular place. So currently it's like the size of float multiplied by 2, right? So that's how much I have to shift, right? That's how much I have to shift to get to the next vertex. And the last one is that how much I have to shift to get to the next attribute. So you won't be able to understand this right now like clearly, but let's understand that because there is only one attribute, right? We are only using one attribute in this current data. But let's say we have some attribute here which is a color or something, anything it can be, right? So now we have in one vertex, this is my one vertex, this is my second vertex, this is my third vertex. Now my vertex has two attributes. One is in the location 0, which is vector 2, and then there is location 1, which has some other attribute. So now I have two attributes. So here what this becomes is the size of this whole thing, right? We can just create a struct and then we can just put everything in that struct, and then we can here just do size of the struct and it will just work. For this part, what it is asking for is that in one vertex, how do I get from one attribute to the next attribute, right? So in my vertex I have two attributes. So for the first attribute, I don't have to shift my byte because my pointer is right here and this is the two things which I want to use. But for this attribute, I have to tell it to use it after these 2 bytes, right? After this 4 and after this 8 bytes total, not 8 bytes, yeah, just 4 bytes per float. So this is total of 8 bytes. So you have to shift 8 bytes and then you get the start of this my second attribute, right? So for here it's 0 because we don't have to shift our data anything else. And now my attributes are working. So now I have given meaning to this raw data to make some meaning for the vertex shader to do something on it. We are currently not doing anything, but we'll do it in the future. So I guess that is done. And now we have done this. We have defined our vertex attribute. We'll do clear color. Now we'll do clear color. Now we'll actually do. Sorry, I can't even speak. We'll call a function which will draw whatever that we have specified all this data, all this variable in the state machine of the OpenGL. Now it will use all these things to draw something, right? And to do that, we first have to use our program, right? So we have to use, as I told you, which program we want to use, which are like which shaders we want to use. So we want to use this program here, right? Now we have defined which program we want to use, and now we can call this draw arrays. So there are a couple of functions to draw something in OpenGL. Currently we'll use draw arrays. I think we'll keep using it. So draw arrays takes in that what we want to draw, and we know that we want to draw a triangles, right? So we'll do triangles like this. So because we want to create draw triangles, We can draw stripes and other things, but most commonly we'll be using triangles. And then we also have to define, I guess we have to check it in the here other parameters, so we can just draw arrays for GL4, and then it says the first specify the start index in the enabled arrays, right? So in our data, right, so we have like raw data, like where do we want to start drawing triangles in that data. So I want to draw it from the first thing, right, and then how many triangles, like number of indices to be rendered. So how many triangles, not how many triangles, but how many vertex do I want to draw, right? So currently we have 3 vertex and I want to draw 3 vertex. So I will do this and I will compile, it works. And now as you can see, everything is drawing, right? So now we can draw, a triangle onto the screen. Also now we can change the color here, right? So let's change the color here. So let's do here 0.5 and also here 0.5, and let's check, and it's not working. So did I do something wrong? Yes. So we have to do semicolon here, and now we can change color, right? So as you can see, the colors are different. We can also do this 0.1 and I will get something different color, right? Let's do orange color. So orange color is basically red and there is no green, and then little bit of blue. I think we have to put some green on it. Yes, so now it's orange color triangle, right? That's it. That's how you draw something. Like once you understand all these things, once you start figuring out how the actual pipeline works, it's very simple. Now let's do let's give the color information inside this data, right? What we want is that we want each of our vertex to be different color, and then it should the all color should blend in the whole triangle, right? Let's do that. So we have position, right? The position is x and y coordinate, and then we have color, which are like four floating variables. So we have RGBA, and then we can just define let's just take these colors, copy, and then we'll paste it in here, and then we'll paste here. So currently we'll have these colors, and then we can change these colors. So let's make this 9, let's make this 9. So we have like some different random colors assigned to this all 3 vertex. And now what we have to do is that inside our shader we have to define a location 1, which is vec4 and which is our color, right? So we have to define like this, because this is my color and this color will be used in some way. So this color will be used in our fragment shader. So as I told you, what we have to do is we have to create an out variable. So for out variable we'll use out, or we can just prefix it with f, because it's gonna pass this value to fragment shader. So we can just call f color, and then here what we can do is we can do f color is equal to a color, and that's it, right? And then this color we have to use the same variable name, right, in here as in variable, right? And we can we have to use the same variable name. So now what will happen is that this variable will get passed on in the fragment shader, and now we can use that color as our output color. And now if we do, it won't do anything, right? It will just do crazy stuff because it's not even rendering a triangle properly. The reason is that because we have only defined one attribute and our vertex shader does not know how to handle this data, right? Because the data is different now. This raw data, this just raw plain data is different. Our vertex shader does not understand how to give the meaning because we have only one attribute defined. So we just copy this attribute, we give the location one location. Now it has four elements. It are all they are all GL float, right? They are all GL float, and here our vertex size is different now, right? What our vertex is, so our vertex size is 2 floats and then 4 floats, that means total of 6 floats. So our vertex size is 6 float, and in our one vertex, if we have to take the color value, we have to shift our pointer this 2 float, right? So we have to shift that whole thing by a 2 float, which is our position. So now we have to define that if we want to understand, if we want to take the data of the color, we have to shift our pointer from position byte, right? So basically 8 bytes, and then if we shift 8 bytes, then we get to the color attribute. And so if we do this and if we run, now we have like color triangle. So each of the vertex has its own color, and then they are blending, they get blended in. So that's it. That's how you draw something, and that's how you pass in multiple data through this raw data, and then you give it then you give some form of meaning to that thing. Now we can't write every time we want to do this crazy stuff, right? It is like very simple stuff which you want to draw. Each time we have to draw something, we can't do it, right? So we have to create some form of abstraction, not also abstraction, but some form of usage that it's easy to draw something when you want to draw it, right? So for that, we will create some abstraction and we'll make it a little bit easier, right, when you want to draw things. So for that, we'll do it in the next sprint, and for now that's it. So we can draw a triangle, we have nice colors,